Tonight is September the 11th, 2025. We know what September the 11th is, don't we? I remember it all too well. I worked for Immigration and Naturalization Services at the time. It was known as INS as a contractor. Anyway, we won't get into it, but I remember where I was standing when I heard about all this. Let's hope that doesn't happen anymore. But what this video is about is not about that. I made a video last night showing how to measure IMD, intermodulation distortion, with two audio frequencies into a transmitter and all that kind of stuff. And some questions came up in the comments about how to sample safely the RF and not burn up your little SA. Well, first of all, here's the SA. This is that one they call a Tiny SA Ultra. That's one I was using last night. Got a lot of glare in here, but now an SA is it takes an input signal. You put a signal into it to measure, and it's a very different instrument. Oops, let me see if I can wreck the place. It's a very different instrument from a nano VNA. The nano VNA outputs a signal, and then it does the reflection of, you know, the S11 port or the S21 port. You know, so I don't want to get into all of the detail, but I'm just saying these are two very different instruments. You don't put a signal into this one. It just does its own thing. It's got the signal generator in it. So we're not going to talk about that. We're just going to talk about spectrum analyzers in general. It could be this one, or it could be a great big Hewlett-Packard one, whatever SA you're using. The front ends of them are very, very sensitive. The big SA that I showed on my video last night has it's inscribed right there at the end connector, the input. And it says 0 DC, and maximum input is 30 dBm. 30 dBm is 1 watt. So you want to make sure you're well below that. So you don't get but one chance, and if you overload it, you smoke it, and that's the end of your beautiful and expensive SA. That's the way it works. You got to buy a new one then. Okay, so here's what you do to help keep your stuff safe. This is the way I do it. I don't like to recommend anything, but I will use the word recommend. I don't know if I can get this thing off right here. I'm struggling anyway. I can't. Look, this is called a DC block. Let's see, focus on that. You know, this thing screws out this L, but I used the L on there just for convenience. So that's the first thing I put on my big SA is a DC block. I don't know where I'm going to get any DC into it, but I want to make absolutely certain, no matter what happens, there's not an, oh no, I just somehow accidentally got 1.5 volts of DC into it. So use a DC block. All it really is a capacitor. I wish I could get it apart so I could just show you the whole thing. And then the next thing is you want some sort of a attenuator. These things come in a bajillion different sizes. This one, it's almost worn off. I think it's 20 dB. So, this goes on to my SA. So I can't get any DC into it, and whatever I put in, it's going to be attenuated at least 20 dB. Okay, that's a good place to start. You want to protect the input, whether it's that big HP or this little guy. They're the same. You put a watt of power into it and you smoked it. There's actually quite a number of videos out there. Well, here's a safe way to do it. This works really well. I like these bird line sections. See, this one actually has an element in it. I've actually disassembled some of my station to make this video. I hope I can get it back together. Okay, see, there it is. These line sections are really nice, and I don't see these too much anymore, but those connectors that go onto the bird are kind of unique, and they're kind of a pain to make. They use coax cables, and it's got a very special connector. But you can buy these little things right here. You see what it is to connect to that? This right here connects to, I don't know if you can see it in there, but there's a little tab in there. Yeah, you can kind of see it. There's a little tab right in there that actually touches the center conductor of this as you rotate it around forward and reverse. Anyway, so this makes it really convenient. You can put these things on there, and then you can you notice it's got a BNC connector on it, and then you can put a BNC cable from here to your meter, whatever meter you use. In this case, this is an outboard meter, a little bird 30 microwatt meter. This one it's got some other stuff in it, but you know, you can outboard it, okay? But here's the way that I do it, and nothing goes wrong. This is a pickup. You can see it's a directional, what they call it, directional extractor. Now, this is not exactly the one that is supposed to go in here. This one is a little bit longer for a deeper one, but it works just fine, and these are cheaper. See how this goes in there? And then you can rotate it around. If the power is going this way and you put it right there, you get the maximum amount of coupling. And I do not know the exact attenuation. I don't think it's specified on there. But that'll give you some safe attenuation. You won't smoke your SA if you use one of these. And then you can, if you turn it 90 degrees, and it just almost completely goes away. I don't know what, the attenuation is probably 100 dB when it's cross, you know, when it's perpendicular to the transmission line, because the transmission line, you know, here's goes in here and it comes out there. That's just one straight connection. So this is a very, very good way to start. It'll keep your SA safe. You can actually adjust the amount of coupling. And then, in addition to that, you've got all the BNC stuff. You can take the BNC connector out of there, and if you want more attenuation, then you put it into something like this. These things are all over the internet. See, they're good from DC to a gigahertz. They're only a half a watt, but the amount of power you're going to be getting out of here is going to be down in the milliwatts at the most, more like the microwatts. So these two things work together. You'll win the war. You just will. This is a good setup. Easy to connect with the BNC. See, all this stuff is BNC, and you can put that straight into your SA. Okay, that is the point, the whole point of the video. And then I've got a lot of toys I want to show you. And then, of course, this goes right straight onto your SA. Now you're going to say, well, what about all these SMA connectors? Well, they make, you know, you can buy the same thing in SMA, and I'll show you some of it here in just a minute. You can also use things like this, these directional couplers. Now it's made for 1.9 to 4 gigahertz. You can see that, and it says that the coupling factor is 20 dB right there. But you can use these at lower frequencies too. You can use them in the 3 to 30 megahertz range. The coupling is going to be a lot less. It's probably going to be down 40, 50 dB, but that's okay too. And these are the outputs. And these are non-rectified outputs. We can go, I mean, there's the number of options that we have with all of these toys is just amazing. Here's a little cheaper one. Here's a big one that goes all the way down to 100 megahertz, 0.1 gig. And it's also 20 dB coupling within its frequency range. Now, you can take these guys right here, and if it's in its frequency range or even lower, but you know, you can experiment with it as long as you don't think you have to have everything calibrated. And in most cases, we don't need to know exactly what the power level is. We just need a relative reading, and all this kind of stuff works really good. Same thing with that stuff I just showed you. Now you can take these guys right here, which is nice about these, and you can put right here on the output, Let me show you if I can find it quickly. Okay, where in the world is it? Yeah, right here, look. You can take these things right here and screw these onto it. This is a diode. It's a real high frequency diode. You can screw this thing on right there. And then you can put a meter out here. Just a regular, you know, a regular sensitive microamp meter. So you don't have to have an oscilloscope and everything. And I mean, you're just going to get a reading. You're not going to be doing too much analysis, but it will allow you to see stuff, which comes in real handy. And if you don't want to buy any of this, you can make your own. I made this a number of years ago. I made it for the 2.4 to 2.5 gigahertz range at one time, and I made it so that it drives the 30 microamp movement, in and out, all that kind of stuff. Made out of copper tubing. It's just a whole lot of fun to work with. Obviously, this is just a T. This is just a clamp. It's kind of a fancy clamp. You could use a hose clamp right there to clamp it. And what's inside this, see, here's some other little sensing units. Here's one right here. Well, that'll be easy to explain. See how one side's grabbed. This is the actual pickup right there. And it's going straight into that diode. There's a hole drilled in this, and the diode is mounted through it, and then the diode connects you know, to the center conductor of that RCA connector, and then it hooks to your meter. Let's see, here's some different ones. This one uses a resistor. The resistor is actually the pickup, and then see, there's the diode right there, and it goes through a little feed-through capacitor. Some of them I got kind of fancy with. The other got lots of toys. Here's another one. Same thing again. I used a resistor as a pickup. It goes to the diode. The diode goes straight through there. The reason for all this is to completely isolate this and make it very stable and isolate it from all of this, because once it goes through the diode and it becomes DC, well, you can do anything you want to with it. You know, you can run it across a room on an extension cord. Who cares? Okay, well, that is actually 99% of what I wanted to show, but then got so many toys here. I wanted to show you you can get all kinds of attenuators. I actually use an attenuator like this on my 4CX1000 homebrew amp. This one is rated at, what does it say here? 50 watts, 10 dB. So in case you need to dissipate a little bit of power, you can use attenuators like this. They come in every size imaginable. Here's one. Same thing. These are all the foreign-made ones. Here's some more expensive ones. This is a 30 dB, as you can see, made by Narda. It goes from DC to 11 gigahertz. So these are just great. You don't need this size, obviously, if you're going to be be using something like this and picking off, because the amount of power you're picking off, like I say, is going to be in the millivolt and milliwatt and microwatt range. This is just in case you need to attenuate things at power. And then again, these are all over the internet. They're actually pretty cheap. Oh yeah, well they attenuate from 0, 10, 20, 30, 40, 50, up all the way up to 120 dB. That's a lot of attenuation. That's 10 to the 12th power. So these are worth having. And here's another one. Really exactly the same darn thing. This one attenuates up to 120 dB also, so it's really the same. From DC to practically to white light, you know what I mean? Here's another same thing as this. This is made by Bird. This is made by Coaxial Dynamics. These have different connectors on them. See, they have this little tiny thing right here, so that makes it a little bit inconvenient. You got to have this type of a connector. So, I think CD, Coaxial Dynamics, is good stuff. I don't have a problem with them, but they, I don't know if you can buy outboard type connectors for this, but it's really the same thing. It'll do exactly the same job as the bird. That latches it in. Okay. Well, as far as toys go, I'll just show you an array of toys that I think everybody enjoys. Here's something that is just a catch me out have. You can put a forward one in and a reverse one in. Well, what this is an old RF power analyst that was no good. And I just happened to run across, look at that big meter right there, 30 microamp made by, who was that, SB? Somebody. Anyway, this is a bird line section up here, a dual one. So I'll put a switch on it. This is homebrew. So I can read the reverse one and the forward. And oh yeah, and it comes out, of course. Yeah, here's something I almost forgot to show you. If you really want to get fancy, you could buy this. This is a coaxial dynamics RF tap off, and it may be too tight for me to loosen, but anyway, you loosen that collar right there, and then you can screw this thing in and out and adjust the attenuation. The one thing I think you got to be careful with this, I'm not 100% sure, but I think if you screw the collar all the way up and you screw this thing all the way in, I think you might even be able to make the center contact touch the line that's going through there, and you don't want to do that. I think what I did on the end of this is put a little piece of Teflon on it, so I couldn't do that. But that's a legitimate tap off that would take the place of the line section. Wherever I put it, it's all right in front of me. That would take the place of this right here. You know what I mean? But anybody really serious about their RF needs a line section, in my opinion. Well, that is kind of pretty much it. Here's some other fancy little instruments. This came out many years ago. This is a digital meter for the bird. It's actually made to fit into the bird Model 43. It really works. It doesn't measure any kind of PEP stuff. It just measures average. And then depending on the slugs, it says required bird line section and elements. So this, you've got to have these two things together. And if you've got a dual section, like the one I just showed you in here, you can run two coax cables up to it and flip back and forth between forward and reverse. Yeah, one good way to measure forward and reverse power, you'll notice in this one, this is a 5,000 watt element, and this is a 100 watt element. So I don't run anything at 5,000 watts, but say you're running at 1,000 watts, so you got a different element. So you got a 1,000 watt element and a 100 watt element, and you want to measure your reflected power more accurately, then you need a smaller power scale. So that works really well for that. I am really pleased with this. This is a regular bird 30 microamp movement, and it's built into this little box, and there's the input from the line section again. Again, you got to have one of these. and the BNC connectors make it really handy. And it's got one of those $54 peak reading boards in here that are all over the internet, and they work. And reads the PEP. If you turn it off, it just reads the average, and it'll measure 2x, 1x, and 5x. So with a 1,000 watt element, right there is 1,000 watts full scale. There's 2,000 watts full scale, and there's 5,000 watts full scale. So it's really pretty cool. I do recommend these. These are quite nice. You get to calibrate them. You have to have some way of calibrating them. And some people say that they don't like them. They don't think they're accurate enough. Well, to me they're accurate enough. You know, we don't need to measure 800 watts down to 1 watt. You know, we're not going to say, I'm transmitting at 802.7 watts. Come on, guys. Get real, you know? Okay, let's see. Now I'll show you that here's another pretty little tap off. It's got the general radio. These are called GR740. I can't remember what they're called now. A variable on Tektronix, so that you can go from 0. It's got a little adjustment here. It says power is going that way. You can go from 0 to full blast. This is, of course, after. This is the fine-tuning part of it. This is, of course, after you've made yourself. I keep going back to that. Really safe with this. If you're using this, you're not going to burn up your SA. Here's some older ones made by Micro Match. It states 50 dB attenuation. That's a lot of attenuation. 50 dB is 10 to the 5th power, which is a factor of 100,000. So it'll turn 100,000 watts going through it into 1 watt coming out, which is obviously we're not going to put 100,000 watts through it, but that's what its attenuation is. There's all kinds of attenuators. Let's see. These are actually not attenuators. These are just terminators, so that you got 50 ohms or whatever you might need. Here's a funny little pick-off. This one is for I think the 2.4 gigahertz range. Like I said, I used to do a lot of playing around with that. And if you notice, if you probably can't see it too well in the camera, but it comes in, it's got a little trace and it stops right there. And this one stops right there. And then it's got this U there and a U there and a U there, and that's the capacitive coupling between the two. So there's no DC. So you've got probably like a, I don't know, probably a fractional picofarad connection between the two. I've never actually measured it, but that's another type of stuff that you can use way up in the gigahertz range. As far as attenuators go, if you like these, see, these are direct attenuators. This one is DC to 8 gigahertz, 3 dB, so it's not a whole lot. But this one, you know, I'll just use this as an example. See, it'll just screw right on there, so you can get these little SMA type attenuators. So, you know, this selection is basically endless. But it all goes back to tapping off of the main power line. Now, I've seen where other people use resistor tap-offs. They'll put like a 10K resistor actually touching the middle of the line, like if you're going to use BNC connectors or PL259s or whatever, and you're actually going to attach it directly to the center conductor. And I wouldn't do that. You could use like a 10K 2 watt, maybe a couple of them in series, and then maybe 100 ohm one. You'd have to do the math to figure out what your attenuation is down at the end, and then you take off from there. There's really nothing wrong with that if that's the way you want to do it. But I personally like the idea of, where is it now? I've lost it again. I personally like the idea of this. See, this is Teflon. Nothing is touching. You're not going to get any DC out of this. None whatsoever. What's inside here, if you take all these things apart, there's just a strip of metal going across there. And it runs parallel with the line in there, so it's just up there next to it. So that, in my opinion, is the way to keep your instruments safe. The only one that I think I've burned up 2. I hate to admit it, but I did. And it was kind of a fluke. I had one of these nano VNAs, and I was trying to measure the input impedance of the grid of a big tube. It was an 833A. I built an 833A a number of years ago and ran it on 20 meters. And I had it hooked up, and when I turned it on, I just wanted to see the input impedance, but apparently when I turned it on, there was enough of a glitch blast or something that came out of it, and it destroyed my little nano VNA. So that one bit the dust. And I hate to admit this one too, but about 3 years ago I was building a radio telescope for the 1.4 gigahertz, the hydrogen line, so we can look at the hydrogen spectrum in the nebula, because I like astronomy too. And what happened there is I was using a 1-watt amplifier. I haven't brought everything in here that I have, but I just wasn't paying attention. And I don't know, somehow I loaded that 1 watt into that Hewlett Packard head. I should have brought it in so I could show you what it is. Well, there he went. it is no more, and you can't repair them. You can buy them oftentimes on eBay, and you may get a good one. But if somebody has overloaded it, well, you don't really know what you're buying. You better buy one that you can return. If it says used, this is the way I understand it. If it says used on eBay, that means it has to work. I mean, if it says parts are repair, well, then you bought it and it's yours, and you can't. They won't help you send that back. But if you buy one that says used and it's been smoked, you can return it. You have to go through the eBay stuff, but I've actually had quite good luck with it. I'm not out to promote or pump eBay, but I really had really quite good luck with them, honestly. Here are some other types of things to measure. This is back up in the gigahertz range. Well, see, from 0.1 to 1.5 gig. When you put the signal in, you take the signal out, you terminate it up here. Yeah, I think everybody knows what these little guys are. These are how you calibrate your nano VNAs. You have an open, short, and a load, an OSL, or I guess you could turn that around and call it an SOL, or whatever you want to call it, short, open, load. As far as terminators go, you can make your own. These things, it won't come apart right now because but these things screw apart. So if you need terminators, and I measured it at 74.7 ohms, so I try to get them right on. I like my measurements to be as accurate as I can. Same thing here. Most of these things come apart. See, that's a 600 ohm one for audio. Audio, yeah, this is no. There's a 50 ohm one, 49.8 ohms. They're actually quite accurate. These are just 50 ohm terminators. Okay, well, I talked the camera. I think the camera only records for like 20 minutes and it shuts down, and you have to make another one. I don't know if there's any way to defeat that or not, but I've probably talked long enough on it. Here's something that I find fun to play with. It's just a gigantic meter. I think this is like a 100 microamp. Well, there it is right there, 100 microamp. No, 100 microvolts. No, that's its input. Anyway, a little bit of a tap off. The same kind of a setup for this, and you can watch your modulation. This right here makes it variable so that you're not banging it against a side, so that you're getting a good reading. Just so that you can. I think it's good to have a number of things that show things are working. This kind of makes sense to me. You can glance around at all your meters or what have you, and this is working, this is working. I mean, just in case you try to load up to your antenna, or maybe it's windy outside or whatever, and it blows your antenna down, and all of a sudden it's like, what? And then you'll be able to see it on some of your meters. And again, you're not actually trying to accurately measure some parameter like voltage or current or power or whatever. You just need some sort of a visual indicator of of what's going on. So there you go. I'll also put a link in here to one by Alan, W2AES, I think is his call. He does a really good job. Probably all of you guys that watch amateur radio videos on YouTube have seen a lot of his stuff, and how he explains it. He's actually very good. Well, anyway, that's enough of that. Hope this helps and keeps your SA from being smoked. Stay safe, my friends. Thanks for watching. Okay, one last thing I forgot. You know, when we comment to each other, like when you comment to videos, they do not get sent to my email anymore. That eBay stopped that. I don't mean eBay. YouTube stopped that. So I do not get notifications. When I comment back to you on the video, for example, when we're trying to have a discussion about it, I don't know if you get an email for it or not. I'm assuming you don't. I've looked into it. I've asked ChatGPT about all this, and you just get kind of a runaround nowadays. Like, well, yeah, you know, you can go in and you can do this and you can do that and blah blah blah. Well, it doesn't work. I'm not trying to be upset about it, but they've just stopped it. And I know things change. You know, the world changes, and nothing we can do about it. But that is unfortunate in my opinion, because the conversations that we have I enjoy them. I learn a lot from you guys. You say, well, what about this and what about that? And I go, wow, that's a good idea. Or why don't you do it this way? I'm glad you know, I really appreciate that type of exchange of information. So I'm asking a question here actually, and that is, when I post a video and you make a comment and I comment back to you, do you get an email? Or do you have to go back into the video, the posting, and read the comments? That's what I have to do. I have to go back into my own video and go down through the comments, because I don't get any notifications at all. And apparently there is no way to turn that back on. I'm sure it's got to do with clicks and money, and that's just the way the world works. Just thought I wanted to ask that though, so I can really get it straight in my head from, you know, from the real world, and not all this runaround that you get when you try to ask questions. Because I don't know, it frustrates me that all too often, whether it's YouTube or ChatGPT or whatever, they don't want to answer the question directly. They just want to kind of smooth it over, and you just kind of shake your head and go like, whatever, and you just go away. Sorry for the rant there.